Alright guys, we're going to be looking at trigonometry and how to solve problems with trigonometry. So our first process that we're going to look at is being able to label the sides of a right angle triangle with O, H and A. Once we can label our triangle with O, H and A, we need to then choose the correct trig ratio that we're going to use. And then the third thing we need to be able to do is be able to solve for the unknown side or angle. Okay, so before we start examples, let's go back and remember what our three trig ratios are. So remember in class our three trig ratios we wrote down. Our first one was sine of theta was equal to O over H. There's our first ratio. Our second trig ratio is cos of theta is equal to A over H. And our third trig ratio was tan of theta is equal to O over A. Now remember, this theta is just simply a Greek symbol that represents the angle that we're going to use inside our triangle. That's all it represents. Alright, the O side, now this side is the opposite side to the angle we're going to use. The H side, this is the hypotenuse side, the longest side in the triangle, and it's always opposite the right angle. So the H side is opposite the right angle. That is the little square box that we have inside our right angle triangle. Now the A side is the adjacent side, and look, that's the side that's left over, or it's the side that's next to the angle that we're going to be using as well. Alright, so let's look at an example. Our example is going to be looking at finding the unknown side, or the variable that is on the unknown side. So here we have our right angle triangle. We've got 12x and we've got 60 degrees here. So we've got to go back and think about the steps. So remember, the first step there we've got to do is label the sides of the triangle with O, H and A. Once we've done that, we need to choose the correct trig ratio, and then we need to solve for the unknown side or angle. Okay, so labeling our sides with O, H and A. Now H is always opposite our little right angle. There it is there. O is opposite the angle, and A is on the adjacent side to the angle. Now we've got X and O, 12 and H, so we don't need A. Now we need to choose the correct trig ratio that we're going to use. Alright, so remember we're dealing with O and H here. Alright, O and H. So if we go back and look at our trig ratios, which of our trig ratios have O and H? That's it, the first one there, sine. So therefore sine of theta is equal to O over H is the one we're going to use. Now we need to substitute the correct values in. Alright, so that's in order to solve this problem, we've got to be able to substitute those values in and then solve it. So on the O side, we've got x. So let's replace that O with an x. On the H side, we've got 12. So let's replace H with 12. And the angle there is 60. So let's replace our theta with 60. Now what we need to do is solve. We're dividing by 12. So we bring it to the other side, it becomes times by 12. And then we use our calculator to just go 12 times sine 60. And that's going to give us a nice answer there of 10.4. And there's our first example of finding the unknown side on a right angle triangle using trigonometry. Nice and simple. Okay. Let's look at another example, remembering those steps. We got 15y and we got an angle there of 72 degrees. Alright, so there's H, there's O, there's A. Label our sides. Circle A and H, get rid of O. Now we need to choose our correct trig ratio. There we go, A and H gives us cos. So we're going to use our cos trig ratio, and we need to substitute the values in. So again, our angle there is 72, so let's replace theta with 72. Our A is y. Our H side's got 15 on it. Now we simply need to solve. We bring that 15 across and it becomes 15 times cos 72. That's going to equal our y. Use our calculator. We're going to get y is equal to 4.64. So again, remember, label the triangle OH and A, choose the correct trig ratio, and then simply solve. We'll substitute in, and then we're looking at solving that equation here to get 4.64. Alright, so we'll look at another example. Here's our right angle triangle. Again, let's just label a few things on here. We've got M, 20 and 40 degrees. Let's label our triangle H, O, and A. Now let's circle the O because it's got an M there, A with a 20 there. Choose our correct trig ratio, O and A. That's going to give us tan. Tan of theta is equal to O over A. And let's substitute those points in. So theta is the angle, so we're substituting in 40 there. Our O side's got M on it, so we want to put an M in place of the O, and A's got 20 on it. And now we simply solve, so it's divide by 20, so we've got to multiply by 20 by bringing it onto the other side, and we get on our calculator and go 20 times tan 40 is equal to M, and therefore we get M is equal to 16.8. Nice and simple there. Remembering those steps, let's look at another example here. Remembering we've got to label the triangle OH and A. We've got 5.5, 12 degrees, and we've got our unknown R. So there is the H side, that's the O side, this is the A side. We're using O and H, which again, we're looking at using the first trig ratio of sine, O over H. Substitute the values as sine of 12 is equal to R over 5.5. Alright, we're dividing by 5.5, so bring it on the other side, it becomes times by 5.5. We get 5.5 times sine of 12 is equal to R. Therefore we get R is equal to 1.14. Alright, let's look at another example here. We got 70 degrees as our angle, we got T, and we got 9. What I want you to do is I actually want you to see if you can get an answer of 24.7. I'll give you a little bit of time. You try and work it out. So here we go. We label the sides. We're using O and A, so it's tan. Tan of 70 degrees is equal to T over 9. 9 times tan 70 is equal to T, and therefore you get T is equal to 24.7. Alright, you would have noticed that most of the, in fact all the variables in those were on the top of our ratio, or the top part of our fraction. So we're going to look at some that have the variable or the letter on the bottom. So same steps as we used before, we need to label the triangle OH and A. So here we go, we've got A and H, which is our cosine function. Cos of theta is equal to A over H. We substitute the values in. Cos of our angle is 34, so cos of 34 is equal to, our A side is 12, so we put 12 on top, and our H is B. Now we've got our B on the bottom. Now to solve this, we can use a technique where we can simply just swap them. Alright, but the understanding behind this, I'll show you quickly why we can swap them. If we get rid of that B, we're going to times it to the left hand side to get B times cos 34. To remove the cos 34, we divide both sides by cos 34. Giving us B is equal to 12 over cos 34. But a nice little technique to make this quick is by simply swapping B and cos 34. So there we go, we can just swap those. Alright, let's look at using this technique. Remembering this is when the variable or the letter is only on the bottom part of our ratio or fraction. Label the triangle OH and A. There we go. We've got 10 and 0, Y and H. We're using O and H, therefore we're using sine. So sine of theta is equal to O over H. There's our trig ratio. Substitute the correct values in. Sine of 20 is equal to 10 divided by Y. And our letters on the bottom, so we can swap that with the sine of 20. Swap those two to get Y on the left is equal to 10 divided by sine of 20. Remembering the sine 20 goes on the bottom part of our fraction. We use our calculator to solve this to get Y is equal to 29.2. And so all we have to do there is just swap those. Nice and easy.